Hello everyone, this is Kalpana here. In this video we're going to see a problem from differential equations. So let's get going. Problem: given equation 1 by x square plus 1 by y square into dx plus ax plus 1 by y cube into dy equal to 0, determine the constant a such that the equation is exact and solve the resulting exact equation. So we are given a differential equation and here we need to find this a, assuming that the given differential equation is exact, and later we'll find a, we'll find a and then we'll substitute a in this equation and then we'll find the reduced equation, not reduced equation, we can say it as resulting exact equation. Okay, resulting exact equation. Fine. Now coming to the solution, given differential equation, (1 by x square plus 1 by y square into dx plus ax plus 1 by y cube into dy equal to 0. Consider as equation 1. Now assume that, so this equation is of Mdx plus Ndy equal to 0. It's dy, right? Form where m equal to 1 by x square plus 1 by y square and n equal to ax plus 1 by y cube, or we can write this as ax by y cube plus 1 by y cube, right? Now assuming that 1 is exact, then dou m by dou y equal to dou n by dou x, right? Dou by dou y of m, 1 by x square plus 1 by y square equal to dou by dou x of n, ax by y cube plus 1 by y cube. So in LHS we need to find partial derivative of this function with respect to y, and in RHS we need to find this function with respect to x. So here x is treated as constant and here y is treated as constant, right? Then dou by dou y, that is partial derivative of first term in the LHS plus partial derivative of second term, which is 1 by y square, equal to partial derivative of first term ax by y cube plus partial derivative of second term 1 by y cube, right? If it is partial derivative with respect to y, then x is treated as constant. So here we are having x, so we will treat this as constant, and here a by y cube is constant since we need to find partial derivative of this function with respect to x, right? So a by y cube is constant and here 1 by y cube is constant since we need to find this function, partial derivative of this function with respect to x. So here 1 by y cube is constant. Okay, this gives us partial derivative of a constant with respect to y is 0 plus dou by dou y of 1 by y square can be written as y power minus 2 equal to, here a by y cube is constant, we can write this as a by y cube into partial derivative of x, right? Plus partial derivative of a constant with respect to x is 0, right? Then this gives us partial derivative of y power minus 2 with respect to y is minus 2 into y power minus 2 minus 1 equal to a by y cube into partial derivative of x with respect to x is 1, right? This gives us minus 2 into y power minus 2 minus 1 is minus 3 equal to a by y cube. Since we know that x power minus n can be written as 1 by x power n or reciprocal of x power n, So we can write y power minus 3 as 1 by y cube. Okay. Now we can write this equation as minus 2 into 1 by y cube equal to, we can write a by y cube as a into 1 by y cube, right? You can cancel 1 by y cube, which gives us minus 2 equal to a, that is a equal to minus 2, therefore a equal to minus 2. So we got the value. We are asked to find constant a, right? So we got a equal to minus 2. Now we need to substitute a in this equation 1. One becomes 1 by x square plus 1 by y square into dx plus a minus 2 into x plus 1 by y cube into dy equal to 0. This gives us 1 by x square plus 1 by y square into dx plus minus 2x plus 1 by y cube into dy equal to 0. Okay. Now we need to solve this equation because we are asked to find the resulting equation. I mean, we are asked to solve, not find. We are asked to solve the resulting equation after substituting the value a in the given equation. We'll get this equation, and now we need to solve this equation. Okay. Solve the exact equation, the resulting exact equation, which is nothing but this is an exact equation. Let's see whether it is exact or not. This is of Mdx plus Ndy equal to 0 form, right? Where m equal to 1 by x square plus 1 by y square and n equal to minus 2x plus 1 by y cube, or we can write this as minus 2x by y cube plus 1 by y cube, right? We are having m equal to 1 by x square plus 1 by y square. Just substitute a in this, then we will get this one. Okay. Then n equal to minus 2x by y cube plus 1 by y cube. Now let's see whether this equation is exact or not for our convenience. Okay. Let's find partial derivative of m with respect to y and partial derivative of n with respect to x. We have m 1 by x square plus 1 by y square. Here we need to find partial derivative of m with respect to y. Since we are finding partial derivative with respect to y, so x is treated as constant. Here 1 by x square is constant, right? This equals to dou by dou y of, and we can write this as, right, partial derivative of first term plus partial derivative of second term. Since 1 by x square is constant and we need to find partial derivative with respect to y, so this becomes partial derivative of constant with respect to y is 0 plus dou by dou y of, we can write 1 by y square as y power minus 2. This equals to partial derivative of y power minus 2 with respect to y is minus 2 into y power minus 2 minus 1, which gives us minus 2 into y power minus 3. Since y power minus n is 1 by y power n, or x power minus n can be written as 1 by x power n. So we can write y power minus 3 as 1 by y cube, which gives us minus 2 by y cube, right? So partial derivative of m with respect to y is minus 2 by y cube. Let's now find partial derivative of n with respect to x. We have n minus 2x by y cube plus 1 by y cube, right? Here we need to find partial derivative with respect to x, so y is treated as constant. In the first term, minus 2 by y cube is constant. In the second term, 1 by y cube is constant, right? Now we can write this as dou by dou x of first term minus 2x by y cube plus dou by dou x of second term 1 by y cube. Here minus 2 by y cube is constant into partial derivative of x with respect to x plus partial derivative of constant with respect to x is 0. This gives us minus 2 by y cube into partial derivative of x with respect to x is 1. This is equals to minus 2 by y cube. Therefore, partial derivative of n with respect to x is minus 2 by y cube. Okay. See here, if you observe these two, we can say that partial derivative of m with respect to y equal to partial derivative of n with respect to x, right? Therefore, partial derivative of m with respect to y equal to partial derivative of n with respect to x. This shows that the resulting exact equation, that is equation 2, is exact, right? Now let's solve equation 2. We know that the general solution to exact equation or of exact equation is given by integral Mdx treating y as constant plus integral terms of n free from x into dy equal to c, right? Let's find each integral separately. We have m 1 by x square plus 1 by y square into dx. So in this integral we need to treat y as constant. So here 1 by y square is treated as constant. This gives us integral 1 by x square into dx, and we can just write this as, right? And here 1 by y square is constant, so we'll write the second integral as constant into integral dx, right? This is equals to integral, we can write 1 by x square as x power minus 2 into dx plus 1 by y square into integral dx, right? Since x power minus n dx, since we know that integral x power n dx equal to x power n plus 1 by n plus 1 for n not equal to minus 1, right? Then for n equal to minus 2, we'll get x power minus 2 plus 1 by minus 2 plus 1 plus 1 by y square into integral dx is x, right? This is equals to x power minus 2 plus 1 is minus 1 by minus 2 plus 1 is minus 1 plus 1 by y square into x is x by y square. This is equals to minus x power minus 1 plus x by y square. This is equals to, we can write x power minus 1 as 1 by x plus x by y square, or minus 1 by x plus x by y square. Therefore, integral Mdx treating y as constant equal to minus 1 by x plus x by y square. So the result obtained from the first integral is 1 minus 1 by x plus x by y square. Now coming to the second integral. Integral terms of n free from x into dy. We are having n, which is minus 2x by y cube plus 1 by y cube. In the first term we are having x, so we should not take this one, and in the second term we are having 1 by y cube, which is free from x, right? So we'll have 1 by y cube here. This is equals to integral. We can write 1 by y cube as y power minus 3 into into dy. This is equals to y power minus 3 plus 1 by minus 3 plus 1, which gives us y power minus 3 plus 1 is minus 2 by minus 2. Or we can write this as minus 1 by 2 into y power minus 2. Or we can write y power minus 2 as 1 by y square, which gives us 1 by 2y square, right? So the result obtained from the second integral is 1 by 2y square, right? Now coming to this, see here you're having minus, right? So the result obtained from the second term is minus 1 by 2y square. Result obtained from the first integral is minus 1 by x plus x by y square, and the result obtained from the second integral is minus 1 by 2y square equal to c. Now let's take the LCM of x, y square and 2y square. Okay, or x into y, xy into y is xy square into 2 is 2xy square. 2xy square is our LCM. See, in the denominator first term we are having x, so close this x and multiply this minus 1 with y into 2. So you'll get y square, that is 2y square into minus 1 is minus 2y square. And in the second term, in the denominator of second term we are having y square. Y into y is y square. Just close this 2 and multiply x into 2, 2x to this x. Then we'll get x into 2x is plus 2x square, right? And in the denominator of third term, you're having 2y square. Just close this 2 and multiply this x to this 1. Then we'll get minus x equal to c. Now take this denominator to RHS, then we'll get minus 2y square plus 2x square minus x equal to 2cxy square. Or we can write this as 2x square minus 2y square minus x equal to 2c into xy square. Okay, this is the required result. Or we can write 2c as some c. Then we'll get 2x square minus 2y square minus x equal to cxy square, which is required solution to our problem. So we have seen a problem from differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.